Hello all, welcome to Excel Academy. So today, as for I told you with respect to the yesterday's topic, that is DSP, I told you that I would be taking care of what, that is I would be teaching the what I can say, the calculator topic, as well as this particular one question from which one, that is one question from what I can say, the question paper, that is which question paper, this one. I told you that I would be teaching. Just a minute, students. I'll open the what I can say, the question paper for you. Just a minute, students. I'm so sorry. Let me check which one is that particular question. No, not this. Okay. So here is my question paper, wherein we have got a question on what I can say. Just a minute, students. I'm going to check it out and showcase to you. This is one. Hmm. This was a question paper. So we have discussed with this question already, but we haven't discussed with respect to formula method. So formula method only have to start teaching you, right? So we learned with respect to matrix method, the DFT as well as IDFT. On the same basis, you have to solve all the other, what I can say, the problems, right? All the other 4-point DFT problem with respect to matrix method. So that is why I taught you. So inverse discrete Fourier transform, I also taught you yesterday, and you're going to work on the same, right? Yes, work on the same for all the others, and please to watch those videos without fail to understand what is matrix method, and you have to see through introduction to DSP part 2. In that you have one question on matrix method, that is this particular question, and I have taken another question, other different question on matrix method, that is problems on matrix method I've showed you, that is cost question, and the third one what I taught you yesterday, right? What I taught you yesterday, that particular 4-point DFT one question, and inverse what I can say, IDFT problem with respect to which one? With respect to, that is this one only have taught by using matrix method. So the same IDFT process you are going to make use of, and you're going to solve for all the others without fail. You need to see that, and you need to substitute the same. What you have to do? So first you have to get, what I can say, to substitute the same 1 by 4 into the W4 matrix. You are going to substitute the same, and then after the W4 matrix you are going to multiply the DFT of that resultant, or whatever the question is given to you, to find IDFT of the following, whatever is given in the question, that you're going to substitute, and you're going to work it out on the same basis and get the resultant, right? So that is why I'm telling you, if you see one question, if you see how to solve one question, the procedure how to solve that particular question, so you can easily solve all the other questions without fail. That is why I told you this subject is like that, and please do try to solve starting from today itself, in the sense starting from today itself. I guess your classes have been started, so please do try to work it out from today itself without fail. Please do go according to the syllabus. Yesterday I told you one important thing, please do watch my video, would get to know how to start studying that particular subject. Have your textbook, have along the reference book along with the textbook. You can have D Ganesh to our technical publication. Try to what I can say, take the question papers, that is 18 EC 52 is a question paper that you have to take, right? For you, your subject code is 20 one, what I can say, I guess 21 EC 32, 21 EC 42. Let me just check with the what I can say, the subject code. But what you have to do is, your syllabus is same as 18 EC 52. So 18 EC 52 DSP students, whatever they have the syllabus, the same syllabus you people also have, the same syllabus is carried. So therefore what you have to do is, you have to what I can say, just follow the question papers of 18 AC 52 without any hurdles, right? You have to, if you have any confusions, please do try to check with 18 AC 52 syllabus and 21 EC 42 syllabus. You will get to know. I'm telling you, check it with it, and I'm telling you. So now I'll try to showcase you at the end. Okay. I'll try to showcase you at the end, or I'll try to put a separate video on that, so that it will be more clear. Okay, and please do what I can say, take 18 easy 52 question papers, and please do keep it and have a syllabus along with the textbook, and then start solving it, right? Yes, I'll also tell you how to demonstrate what I can say, the particular I mean how to start studying. I'll demonstrate, I told you. I'll also do that without fail. And now let us come to this particular. So this is x of n is equal to 0, 1, 2, 3, and verify the results with IDFT method using formula method. So here we are trying to solve it using formula method, and before that I need to showcase you one thing, that's the calculator. So yesterday we just discussed about what? So yesterday we just discussed about the what I can say, the magnitude and the phase angle, right? Yes, let me showcase today the magnitude, the phase angle I'll show in the next video. So see magnitude. So see here it is hypotenuse. On the top of hypotenuse you have ABS, right? ABS and C. So what is supposed to do? You're going to first switch on the calculator. See your calculator switch on. Now click on shift and now click on this ABS. So it's showing you the magnitude. So before that, now what you're supposed to do is you're going to keep it in what I can say, your shift mode, right? Your complex 2 mode. So that is why I'll press, just a minute, I'll press mode setup. Now my mode setup is pressed. See, this is what is my mode setup, and I have 2, that is complex. So this one I'm going to press, I'll press 2 here. After I press 2 here, so what I have to do is I have to take once again shift, and I have to take ABS. So here what I have to do is I'll showcase you one example. Just a minute, students. Yes, yesterday's problem only I'll showcase to you. So see here. So in the yesterday's problem, the resultant that we have got is, so that is 10. The resultant that we have got is what? 10 minus 2 plus 2j minus 2 minus 2 minus 2j. But what is the matter is, you don't want to put your numericals out here. So don't put this 10 over here and get the resultant. You will get it as 10 here, right? So for numericals, what you're supposed to do is you're going to write the same, right? This is modulus of 10, so you're going to get it as 10. Now here you're going to once again put, that is once again switch it on. So now you have to take shift again your ABS, and you are going to take what I can say, minus 2 plus 2j, right? Yes, minus 2 plus 2I. So what you're going to get? You're going to get it as 2 root 2, right? You're going to get it as 2 root 2. Similarly, what you're supposed to do is, yesterday I told you that for a numericals, what you have to do, you have to write it directly. But sometimes it doesn't work. Why? Because here you have minus 2 as a numerical value, right? If you put minus 2 modulus, you will get it as plus 2, right? Then for 10, what happens? So then for 10, just a minute, I'll once again take it. Then for 10, what happens is, just a minute, I'll take shift again. I'll go to this. If you take 10 over here, it will provide 10 only. But if you take minus 2, but if you take, just a minute, students, I'm sorry. Yes, but if you take minus 2 here, it will provide it as 2. For 10, it provided as 10. But for minus 2, here it provided as 2 here. So therefore, what you have to do is, for negative values, whatever you get as a resultant, that is for x of k or x of n. So you're going to put it for modulus. You're going to put it for modulus of minus 2. So you get this resultant. For negative values, you try to put it, right? Yes. And then now here once again you have to take it shift. So it is what I can say, my ABS, and here is what? Here is what I can say, that is minus 2 minus 2I, or I get my resultant as what? That is 2 root 2, right? This is what is I get it. This is how we are going to what I can say, do with respect to the calculator. That is with respect to finding out the what I can say, your this one magnitude, right? Now I found out the magnitude, and phase angle I'm going to tell you, so please to wait. And now let me move on to what I can say, the this particular question now, right? If I come to this particular question, so let me take my Microsoft Whiteboard. So the my question is, what I can say, this one, that is your x of n is equal to 0, 1, 2, 3. What is my x of n? This is what is my question. So what I have to do, I have to simplify using what I can say the this one. Which one? That is my formula method. So what is my formula? I know that my x of k formula, which is equal to this. I am going to tell you in a very simple manner. So please to understand, please to see the one step and do follow. For all others you have to do follow the same, right? Yes. So that is why what I have to do, this is what I can say my n minus 1 to, just a minute, this is n minus 1 to n is equal to 0, that is x of n into e to the power of what? E to the power of, that is minus j 2 pi by n into kn, right? Yes, minus j 2 pi by n into kn, and then yes. So this is what is my formula, and then now what I have to do is, very first step I have to do, I have to take my k is equal to 0. My k is constant and my n values are, that is what I can say the 0, 1, 2 and 3, right? Yes. So now what I am supposed to do, I have to take k is equal to 0 first. So I get it as what? Now here how to substitute. I'll tell you how to substitute, just a minute students. So this is my n, which is what is my number of samples, right? This is what is my n, that is number of samples, and this is what is my n, that is which ranges from the 0, 1, 2, 3, and this is k is my constant, that is 0, and n varies from 0, 1, 2, 3. Now I'll just write it as x of 0. Please to adjust students. Yes, x of 0 into what I can say, e to the power of what I can say 0. Why e to the power of 0? It is because here you substitute minus j 2 pi by 4 into k is equal to 0, n is equal to 0. So this whole thing into 0, this e to the power of minus j 2 pi by 4 into 0 is obviously 0. So directly you get it this. And now here you can write it as, that is x of 1 into e to the power of what I can say 0. Why e to the power of 0? But my n is 1. Here this n is 1. Now see here your n is 1 now. But my k is always 0. So that is why I get it as x of 2 into x of 2 into e to the power of what I can say my 1, that I can say my 0. I told you your k is 0 but your n values are varying. If you multiply anything by 0 you get it as 0, and this whole thing, that is e to the power of minus j 2 pi by 4 into 0 is obviously 0. So now let me take, that is equal to x of 3 into, so that is e to the power of 0 once again. So now what is my x of 0? My x of 0 is 0 plus what I can say my x of 1 is 1. This one only is supposed to, this x of 0, just a minute I'll write it, this is x of 0, this is x of 1, this is what is my x of 2, this is what is my x of 3, right? Yes. Yes, so this is what is my x of 3. So I'm going to get my resultant as 0 plus 1 plus 2 plus 3, right? Why 0 plus 1 plus 2 plus 3? Here it is e to the power of 0, which is always 1. Anything to the power of 0 is 1. So if you multiply the 0 into 1 you get 0, 1 into 1 you get it as 1, 2 into 1 you get it as 2, 3 into 1 you get it as 3. That you all know, right? Yes, and now you get the resultant as what? You get the resultant as 1 plus 2 is 3, 3 plus 3 is 6. So you are going to get it as 6, and 6 plus 0 is 6. So finally you got it as 6, right? So now what you're supposed to do, you have to just take the k is equal to 1 now. So I just have to, what I can say, just a minute students. Just a minute students, I'm so sorry. So I'll just a minute students, I'll just wait a minute. Yes. So now I guess you got all these things, right? Yes, I guess you got all these things. So see here, this is what I can say, my formula. So what did I do for my formula? For my formula, just a minute, I'll bring it down. For my formula, I just applied very first my k is equal to 0 and then n is equal to 0, 1, 2, 3. That is what is my procedure. You have to keep k as constant here and your n value, what I can say, it will varies, right? That is supposed to do. So I have substituted k is equal to 0 over here and n is equal to 0, k is equal to 1, k is equal to 0, n is equal to 1, k is equal to 1, 0, n is equal to 2, k is equal to 0, n is equal to 3. You have to substitute and these are all the resultant. I can write it as this is what is my resultant. This one is my resultant for k is equal to 0. Just a minute, I'm so sorry. K is equal to 0 and n is equal to 0, right? Just a minute, students, I'm so sorry. Yes, k is equal to 0 and n is equal to 0. This is what is my resultant for k is equal to 0. My k is equal to always will be 0 and n is equal to 1. This is for n is equal to 2. This is for n is equal to 3. Right? Yes. The k is equal to 0 only. This is for that resultant you got. So now what I am supposed to do is I have to, what I can say, once again use this formula and substitute k is equal to 1 and n is equal to 0, 1, 2, 3. That is what is my step number 2. Right? Step number 2. Yes, yes. So let me substitute k is equal to, what I can say, 1 and n is equal to 0, 1, 2, 3. That is what you are supposed to do. You are going to take constant values of k and you are going to vary it with respect to n. That is, your n value varies from 0, 1, 2, 3. The different combination. That is for k is equal to 1, n is equal to 0. K is equal to 1, n is equal to 1. K is equal to 1, n is equal to 2. And k is equal to 1 and n is equal to 3. For all these 4 combinations, you are supposed to work out, and from that only you are going to get the resultant, that is x of 1, right? Capital X of 1, right? Yes. Just a minute, students. I'll just erase this and let me start doing it. Yes. So now here what I have to do is, I'll just take this color for now. So you have to do as, very first thing you're going to write x of, that is what I can say here. Which one? This is x of, just a minute, students, I'm so sorry. Yeah, I'll take this only. So x of, what I can say, my 1. X of 0. First my n is 0, isn't it? Yes, my n is 0 but my k is 1. Please do remember that. So here also it becomes x of 0 into e to the power of 0. Why x of 0 into e to the power of 0? It is because my e to the power of minus j 2 pi by n into kn. This is what is my given, right? So here if you say, you substitute 4 over here. So I get it as e to the power of, that is minus j 2 pi by 4, what I can say, into, that is your k is equal to 1 and n is equal to 0, right? Your 1 into 0 is what? Yielding me 0. And if you multiply this 0 with this, so you get it as e to the power of 0 only, right? So this is what you have to know. Before you start, what I can say, writing like this, e to the power of 0, you need to know how did that come, okay? So I'll keep this as it is. I'll take the next one. So my next one is what? It is plus. So here there is no minus symbol in any of the values. So I can directly take it as plus. So it is plus x of 1 into. So my n is 1 now. And my k is 1. So my combination of n is 1 and k is 1. That is e to the power of, what I can say, that is, it is minus j here pi by 2. Why pi by 2? Why? How did I get this as? Let me just do it over here. So it is, what I can say, my equation is e to the power of minus j 2 pi by 4 into 2 pi by n into kn. Here my n is 4 and this k is 1 and n is also, small n is also 1. So here I get it as e to the power of, what I can say, minus j 2 pi by, just a minute, student, minus j 2 pi by 4 into 1, or I can get it as minus j 2 pi by 4, which is 2 ones are 2 twos are. So what I get it as e to the power of minus j, that is what I can say, my pi by 2, right? Yes. So now my next thing what I have to do is, I have my next combination, that is k is equal to 1 and n is equal to 2, right? Yes. So I get it as this n is 2. And now here I get it as what? So now here I get it as, what I can say, e to the power of minus j pi. Why e to the power of, that is what I can say, minus j pi, is because, so see here you get your formula. This is what is your formula, that is e to the power of minus j 2 pi by n kl. I will not write that again. So here it is e to the power of minus j, that is 2 pi by, what I can say, 2 pi by 4. My capital N is 4, that is number of samples are 4, and here it is what I can say, 1 into 2. What is 1? 1 is my k value which is constant, and this is what is my n. So I'll write it over here, student. This is n, this is what is my k value, and this is what is my n value, right? So now if I do the simplification, I would be getting it as, just a minute, I'm so sorry for the distraction. So it is minus j, so it is what I can say, that is 2 pi by 4 into 2, right? So now we can get it as 2 ones are 2 twos are, and 2 and 2 get cancelled. So I can get it as, that is e to the power of minus j pi, right? Yes. So now this is what is my third one, and let me come to the fourth one. So this is what my combination of, that is your k is equal to 1. Just a minute, students, I'll write each and everything to you because you understand it in more clear manner. It is what is your k is equal to 0. Just a minute. This is what is for a k is equal to 0 combination, and n is equal to, what I can say, I'm sorry, just a minute, students, I'll write this again. So this is combination is k is equal to 1 and n is equal to 0. This combination is for k is equal to 1 and n is equal to 1, right? And this is for what I can say, my k is equal to 2. I'm sorry, k is equal to 1 itself. I'm really sorry for the distraction. It is for k is equal to 1 and n is equal to, what I can say, the 2, right? N is equal to 2, and my next combination is k is equal to 1 and n is equal to 3, right? So this is x of 3 into, what I can say, that is e to the power of minus j. It is what? So it is 3 pi by 2. Why 3 pi by 2? I'll also showcase you that. This combination is what? This combination is k is equal to, what I can say, my 1, n is equal to 3, right? Yes. Yes. So now my equation is this only. I don't write it again. So now let me take. So it is e to the power of minus j 2 pi by, what I can say, my capital N is 4, and here it is, just a minute, students, I'm so sorry. My capital N is 4, and here it is, what I can say, my 1 into 3. Right? Why 3? Because my k is 1 and n is 3, and my capital N is 4. So here you get it as 2 ones are 2 twos are. Right? And here you get it as, just a minute, this is, I'll write it downwards, and this is e to the power of minus j pi. Let me write it over here. I guess you're getting what I'm writing, right? Along with that, you're understanding things, right? So please do, if you don't have any issues, you can just, what I can say, a comment in the comment box below, so I can just get to know what is your problems, right? Yes. So this, if I simplify, I would be getting it as, what I can say, that is e to the power of j. So this is what I can say, pi by 2 into 3. Here it is 3. 1 into 3 are 3, or I can get it as e to the power of minus j 3 pi by 2, right? Yes. So minus j 3 pi by 2, and this is what is, you get it, right? Here you got the same, right? Yes. So this is what is my, what I can say, the resultant. So now what happens is that I need this particular, so I'll keep it here itself. So let me take this much. So now here, just a minute. So now here, I'll, just a minute, students, I'm so sorry. Let me come. Yeah, okay, this is my thing. Okay. So now, what you have to do, my e to the power of 0 is always 1. So what is my resultant? My resultant will be 0. First resultant is always 0, right? Yes. And now it is plus, let me take this only. So here it is what? So here it is e to the power of minus j pi by 2. So let me take the calculator. So let me take, where is e to the power? So my e to the power is here. So e to the power is on top of im. So therefore I have to, what I can say, natural logarithmic. It's in the top of natural logarithmic. So what I have to do, I have to what I can say put shift, click on shift and then again this. So you get e to the power of minus what I can say j pi by 2. So here you can't do this in calculator. So I have already told you about this. So sorry for opening it. So I have already told that you have to use a formula called as cos, what I can say, pi by 2, that is minus j pi by 2, right? That formula I told you, minus j sin pi by 2, that you can substitute in calculator. Just a minute students, I'll just write that formula. I already told you about that. So you have to use a formula, that is what is called as your cos, what I can say, that is your formula is that is your cos pi by 2 minus j sin pi by 2, right? Yes, this is what is the formula. So I'm so sorry. This is what is the formula, that is cos pi by 2 minus j sin pi by 2. So now if you substitute this in calculator, where is your cos? Your cos is here. Cos, take this, your pi is over here, your pi is on the top of into 10 to the power of x. So please to take shift and please to take this and divide it by 2, pi by 2. So close the bracket, don't go up and close the bracket and take minus, take j, or you can take I sin pi by 2, here to take, right? Take I sin pi. So here is shift and pi and come down, take 2. Yes. So you're getting the resultant as, what I can say, this resultant. Why? Because you have kept it in degrees. So I need to go to radians once again. So I'll go back to, what I can say, I'll go back to shift. I'll take, what I can say, fourth one. What I have to do, I have to go to shift, and here it is fourth one, that is radians. I'll go to 4, and what I can say, I'll go back to on. I'll do it again. See here, once again I'll showcase to you. So to shift, you're going to take your fourth one. Radian is what? Your fourth one. Now it is in radians now. So it's in radians now. So now what you have to do, you're going to take cos pi by 2. I'll show you one thing over here, interesting thing over here. So pi by 2, what I can say, minus j sin pi by 2. I show all the things is because you understand things well, right? Many of them put it in degrees, and what they do try to, or I can say, solve it, but it is not. You need to put it in radians. That is why I showed how to go. You have to click shift again, and after clicking shift again you get their radians, that is number 4. So I have to click number 4 over here, right? Now I get it as what? Minus I, right? What did I get? I got it as minus I. Just a minute, I'll just what I can say, um yeah. So I got it as what? I got it as, this is as minus j. This e to the power of minus j pi by 2, I got it as what? Minus I. So now I have to write x of 1 is what? X of 1 is what is my 1, right? X of 1 is what is my 1 into, what I can say, that is your what I can say, your minus I, right? 1 into what I can say, the minus I, or this is what is plus, what I can say, that is your 2. Your 2 into, what I can say here, your 2 into, once again this is cos pi minus j sin pi. So here it is cos pi minus j sin pi. You're going to substitute over here, and before that please do look at it. This is minus I. So minus I, where did we get? Minus I, where did we get? Is that we got it in the what I can say, the omega power 4, that is omega 4, the, what I can say, matrix. In omega 4 matrix we got 1 and we got minus I. That minus I is only this, right? That minus I is only this, right? You get it in order itself. What happens here is that, so let me just keep it over here. What happens here is that whatever this e to the power of minus j pi by 2, you got it as I, right? This 2 is not there. Okay, you get it as pi, and here what happens is, here you get it as minus 1, and plus here you get it as what I can say, my 3 into, that is, here you get it as what? Here you get it as, that is plus j, right? That is what I am telling you. Whatever is present in that particular matrix, that resultant only you are going to get it over here. In the matrix you had minus I, minus 1, minus j, minus 1 and plus j. The same thing you are getting. See here, it is minus j. It is minus 1 and plus j. If you see the matrix in row 2, you get minus j, minus 1 plus j. Right? This only you are going to get. Then in the third line you had minus 1, 1 and minus 1. So that only you are getting. And in the fourth line you have that is j. I can say minus 1 and minus j. The same thing only you are going to get. That is what happens over here in the case of this formula method. So now here what I am going to get, if I do simplify this, so I am going to get the resultant as here, this resultant I am telling you now, this resultant I am telling you, I am going to get the resultant as 0 plus what I can say minus j, or I can directly write it as 0 minus j minus 2, and this is plus 3j, right? Yes. So before that I'll showcase you and everything. So see now here I have taken what I can say the cos pi by 2, right? So I'll cancel that and I'll only take it as pi. Just a minute, students. Yes, I'll only take it as pi. What I do, I'll put shift and I'll only take it as pi. While I'll only take it as pi because, so this is e to the power of minus j pi. For e to the power of minus j pi, you get it as cos pi minus j sin pi. For this, you get cos that is 3 pi by 2 minus j sin 3 pi by 2. That is what you get it. Here instead, in the place of pi by 2, you are going to put it as pi for this particular one, and in the place of pi by 2 you are going to put 3 pi by 2 for this particular, right? I'll do that. So here it is, what I can say I sin, I'll just take the students. Yes, so here it is what I can say my, just a minute, I'll go to the, I'll come here. Yes, so here I'll take it as pi. I'm so sorry students, really sorry for the distraction. So I'll go to this only. So here it is shift and pi. So see, this is cos pi minus I sin pi. If I take cos pi minus I sin pi, I would be getting it as what? Minus 1, which I have written it over here. See, this is what is my minus 1, right? The same thing. Now while here, what I'll do, I'll go back, I'll take 3 pi by 2 students. I'll take 3 pi by 2. Now, yeah, here 3 pi by 2. Just a minute. Here also I'll take 3 pi by 2 students. What I'll do? I'll take 3 pi by 2. In place of pi, I'll put 3 pi by 2 because it is what I can say my e to the power of minus j 3 pi by 2. Right? Yes. So now what is my resultant? I got it as I, which I wrote it over here. This is j, right? Yes. So the same thing you get it as a resultant, right? So now what I'm supposed to do is I'll simplify this, which I get the resultant as what I can say the minus 2 minus 2j, right? Yes, minus 2, just a minute, I'll just take it. So minus 2 minus 2j, right? So this is what is for one particular thing. For all others you are going to follow the same. For all others you are going to follow the same. That is why I taught you one particular thing in detail, and for all others you are going to do follow the same, right? Yes, follow this particular. For all others you will getting the resultant as, I'll showcase you the resultant for all others. I'll just keep it up. So for all others, I'll tell you the resultant. For x of 3, for this particular, you are going to get a resultant as what? That is equal to what I can say, that is your this one. That is you get the resultant as, that is minus 2. You have to take k is equal to 2 for this, and your combinations with k is equal to 2 or n is equal to 0, 1, 2, 3, right? For k is equal to 2 and n is equal to 0, for k is equal to 2 and n is equal to 1, for k is equal to 2 and n is equal to 2, for k is equal to 2 and n is equal to 3, you are going to solve the problem. That is always your x of 0, your x of 1. Just a minute, I am going to showcase that also for you. I will make you more clear. X of 1, x of 2, just a minute. Okay, so always this 4 will be the same. This 4 you have to write it as x of 0, x of 1, x of 2 and x of 3. This e to the power of, that is minus j 2 pi by n into kn will vary for each and everything, right? For x of 0 it will vary, for x of 1 it will vary, for x of 2 it will vary. So it is like your x of n into e to the power of minus j 2 pi by n into kn. For this you are going to substitute the values of n. Here it is 0, 1, 2, 3, and here it is k is always a constant, which is equal to 0, 1, 2, 3. That is according to your this thing. So very first, if you take k is equal to 0, you need to keep your k is equal to 0 as a constant, and you are going to substitute the n values, that is 0, 1, 2, 3, right? And then if you take k is equal to 1, you need to keep k is equal to 1 for all the values of n, that is 0, 1, 2, 3. If you take k is equal to 2, you need to keep k is equal to 2 as constant, and for all the values of n is equal to 0, 1, 2, 3, and for 3 also it is the same, and this n is 4. Like that you are going to substitute and you are going to get the result 10. So this is for x of 4. If I see, just a minute, this is for x of 2 students, I am really sorry. Just a minute. This is for x of 2, and if I take it for x of 3 now, so if I take it for x of 3, if I take it for x of 3, I would be getting my resultant as what? That is equal to my minus 2 minus 2j, right? This is what I get it as my resultant. So my d of t is what? So my total d of t is 6 minus 2 plus 2j minus 2 minus 2 minus 2j, right? That is why I showed you for one. For all others it is the same. You can try it out without fail, right? Yes, you can try it out without fail by what I can say, do follow my process, right? The same process you're supposed to follow without fail, right? Yes. So now this is what is I get. So now what I have to do, I need to find my IDFT, inverse discrete Fourier transform. So if I, what I can say, take inverse discrete Fourier transform, you got my DFT like this. This is what is my DFT. That is x of k. For what? 0, 1, 2, 3. So now by using this DFT only, I have to find IDFT. So if I have to find IDFT by using this DFT, so I have a formula for IDFT. So what is my formula? That is 1 by 4, 1 by n. So my n is 4, I took it directly. So first I'll let the formula. This formula is x of n is equal to 1 by n into, that is what I can say, that is a summation of, what I can say, that's a summation of, that is here 1, what I can say, that is x of, this summation I haven't written, I'm so sorry, wait a second students, yeah, so this is summation of, that is what I can say, just a minute, yes, so this is what is the formula, which is equal to, that is summation of k minus 1 to n is equal to 0, yeah, just a minute, k minus 1 to n is equal to, just a minute students, I'm so sorry for the distraction that's happening over here, and it is what I can say, summation of n minus 1 to k is equal to 0, just a minute, I'll take it, here it is capital N minus 1 to k is equal to 0, I just have to put a bracket for it, right? Yes, I just have to put a bracket for it. That is why I just kept all this outside. So, or I can not write the bracket, it is fine. If you don't write the bracket also, it is fine, right? This is 1 by n into summation of n minus 1 to k is equal to 0. This is what is my k, just a minute students. K is equal to 0. And it is what I can say, my x of n into e to the power of, what I can say, minus j 2 pi by n into kn, right? 2 pi by n into kn, right? This is what is that particular. So now here this is positive. For here what I can say, here this one, for here what I can say, your DFT it is negative, for your IDFT it is positive. For this you need not to do a process like DFT. What did we do in DFT is that, just a minute students, I'll just bring it upward. What did we do in DFT is that we just, what I can say, did all this process. See, we just did all this process and we just simplified all these things and we just wrote these things and all. No need of that. You just have a common simplified version for that, and you need to use that version, and from that version only you're going to substitute all the values. So what is that is that I have 1 by 4 into what I can say, that is your x of 0 into that is your e to the power of what I can say, j, that is pi by 2. Why pi by 2? 2 pi by 4 is obviously pi by 2. Here if you take n is equal to 4, so then n is equal to 4, so then you have 2 ones are 2 twos are, right? Yes, 2 ones are 2 twos are, and here your k value you are going to, what I can say, keep it as constant, right? So your k value you are going to put like this. Just a minute students, yes. So you have a standard for this. So this one you got it right. 2 by 4 is obvious. 2 by 4 is obviously 5 by 2. And here it is, what I can say, you have to take it as 1 into n, and this is 0. So here it is 0. So you can directly take it as what? So you can directly take it as, that is equal to what I can say here, x of 0 into, just a minute, I'm really sorry. It is x of 0 into e to the power of 0, right? Here you can take it as x of 0 into e to the power of 0, plus here it is, what I can say, that is e to the power of, that is minus j. Here it is x of 1. I'm so sorry guys. It's x of 1. What I can say, x of 1 into e to the power of, what I can say, that is your j, that is j 2 pi by n, or you can write it as directly pi by 2. So it is better to write directly pi by 2, because you know what is 2 pi by 4. It is pi by 2 into what I can say, that is your n. It is plus, what I can say, it is plus my x of 2 into my x of 2 into, that is e to the power of, what I can say, that is your j. Just a minute, I'm so sorry. I'm so sorry. It is e to the power of j, that is pi by 2 into 2n plus what I can say, my x of 3 into, this is what is my standard form. I am substituting, what I can say, I am substituting the values of, that is k over here. I am substituting the values of k over here, right? Yes, that is what I am doing. So this is pi by 2 into, what I can say here, k is, what I can say, that is your, here it is 3. So 3 into, what I can say, my n, 3n, right? Yes. So now here I have to take capital N. So this is what is my capital X of k, right? Yes, this is what is my capital X of k. We are substituting the values of k over here. There it was x of n. Here it is, what I can say, my x of k. So that is why what I have to do is I have to take capital X here. What I have to do? I have to take capital X over here, right? Yes, just a minute. It is, what I can say, the x of k, 0, right? Here it is x of 0, here it is x of 1, and here it is x of 2, and here it is x of 3. This is what is I get it, right? Yes. So now for this formula you have to substitute your, what I can say, the values of n. So if you substitute the values of n, if you substitute your n is equal to 0, what I can say, n is equal to 1, 2 and 3. So first let me substitute your n is equal to 0. Just a minute students. Wait for a second. Yes. Yes. Now if you substitute n is equal to 0, so what is supposed to get? You are getting it as, this is what I can say my my 6, 5, 6, because x of 0 is 6 for me now. I have to take what? I have to take my DFT that I have got, resultant, that is 6 minus 2 plus 2j, and it is what I can say minus 2 and minus 2 minus 2j, right? I have started this. This we have got as resultant, and by this one you are going to use it over here. So my x of 0 would be this 6. My x of 1 would be minus 2 plus 2j. My x of 2 will be minus 2, and x of 3 will be minus 2 minus 2j, right? So I'll take 6 over here. This is plus this particular, if you substitute 0 over here, you always get it as 1. Here if you substitute 0 for all, so you're going to get it directly as e to the power of 0, which is 1. So that is why you get it as, what I can say, this is minus 2 plus 2j, right? Minus 2 plus 2j, and once again it is minus 2, then it is minus 2 minus 2j, right? Yes, so if you put all this in calculator now, so you are going to get it as, I'll prove it for you students. It is 6 minus 2 plus 2j, and it is minus 2 minus 2 minus 2I, which is providing me 0, right? So now what I have to do, I have to put it equal to 1 by 4, what I can say, into 0, so which is providing me 0. So I got my very first resultant verified, right? Yes. So now what I am supposed to do is, I will do for the next one. So for all others you have to do the same. I'll just take this, I'll just move it out. So how did you get this? I'll repeat it once again. So how did you get it is that this is what is my formula. Just a minute, I'm really sorry. This is what is my formula. So what I did is, here I have to vary my value of k. I need to keep my n constant. My k will vary from 0, 1, 2, 3, and my n is constant. There what happened? My n was not constant. My k was constant in the case of DFT, and I had to substitute the values of n, that is 0, 1, 2, 3. But here in the case of my what I can say, the which one, that is your what I can say, the IDFT, your k value is not constant. Your k value will always vary, and in the case of n it will remain constant. So to take n is equal to 0 for all, and your k combinations would be n is equal to 0 and k is equal to, what I can say, 0, and what I can say, n is equal to 0 and k is equal to 1, and what I can say here, n is equal to what I can say, the 0 and k is equal to 2, and n is equal to 0 and k is equal to 3. Like that it goes on, right? That is what you are supposed to do. So now what you are supposed to do next is that, so you have to just substitute all those things. So here if you substitute, so here it is k is equal to 0, and here also my k is equal to 0. So here you directly get it as e to the power of 0, because if you multiply anything by 0, it is 0 itself. So you get it like this. So here we have taken e to the x of 1. So here you substituted k is equal to 1, and here also substituted k is equal to 1, that you directly wrote it as n, and here it is pi by 2, because 2 pi by 4, e to the power of j 2 pi by 4. 2 pi by 4 is pi by 2, right? And here you substituted k is equal to 2, and here also substituted k is equal to 2, and here you substituted k is equal to 3, and so on, right? Yes, and here we got the resultant, right? And for second one, if you do, I'll do only for 2. For all others it's the same, right? You need to know the standard. This is standard thing you need to know, students, right? This standard thing what you're supposed to do, this standard thing you need to know. This standard thing is really important, and you have to by heart it for sure. Which one you have to by heart? This formula, and this one you have to by heart. These things if you by heart, so what is that going to happen is, this will be helpful for exams. If we ask you to do solve using formula method, this particular thing becomes really important for IDFT. Like you need not to do separately. Like if you know the standard, what I say, can say the equation, you can just directly start solving for all the what I can say, for all the values of n without fail, right? For n is equal to 0, it is the same formula, and substitute n is equal to 0 for all of this. You have to take n is equal to 1 and substitute for all of this. So this equation become a super important equation for you in the case of that is DSP solving using IDFT. What I can say, IDFT, from the IDFT to get a DFT. So this particular formula, that is this important formula, is really important. Please do learn this formula without fail, right? Yes. And now coming on to the second one. So let me do the second one. So for my second one, I get it as, so that is what I can say, my 1 by 4 into, so that is, you have got it as, that is x of what I can say, the 0. Here it is x of 0 into e to the power of 0. This is always the same. It is plus my x of 1 and 2, what I can say, that is e to the power of minus j, that is 2 pi by what I can say, that is here, this is plus j 2 pi by, that is 4, or you can directly write it as pi by 2. Just directly try to directly write it as pi by 2. Here it is pi by 2, pi by 2. So it is what I can say, it is pi by 2 into what I can say, that is 1, right? Or you get it as e to the power of j pi by 2. Why you get it as j pi by 2 here is because it is there, it was for n is equal to 0. So if you multiply anything by 0, it is 0. But now here it is what? But now here it is e to the power of j pi by 2. So if you will get it as, that is cos, what I can say here, just a minute students, I'll just showcase it to you. Here your formula will become equal to, that is what I can say here, just a minute students, wait for a second. So it is your cos pi by 2, it is cos pi by 2. So that is plus Jason. Just wait for a minute students. I'm so sorry. So please do wait for a minute. So it is what I can say. So just a minute. I'm so sorry. Wait for a minute. So I'll just clarify about this to you now. So it is yes. So here my formula becomes equal to, that is your cos pi by 2, cos pi by 2, what I can say, that is plus j sin pi by 2. It is not minus, so it is plus j sin pi by 2. So it is cos x plus j sin of x. X is whatever the value, get it over here, you consider, right? Yes, so this is what is the formula, and for all others you are going to substitute the same. In place of pi by 2, whatever you get, you are going to substitute. Right now if I substitute, I'll substitute what I can say, the cos pi by 2, here is my cos, it is what I can say, my pi by 2. So shift and pi, and here it is downward, it is by 2. So please do follow the arrow marks while using the calculator, right? Yes, it is j, what I can say here, sine pi by 2. Just a minute, I'll have a shift and pi, and here it is divided by 2, and here it is, yes, you got it. Now you get the resultant as I. What is my I? My I is what? That is second row, second row, second one, right? Yes. In the, what I can say, let me write this now. So here I get it as, which is equal to, this is equal to I. So this one will be is equal to I. And now I need to take plus x of 2 is equal to, I'll just tell you about that now. So plus this is my x of 2 into what I can say, the e to the power of minus j pi by 2 into, just a minute, I'll just take this and bring it over here. It is what I can say, my x of j pi by 2 into, so here n is 1 and this is 2. So I get directly as e to the power of minus j pi. So now instead of pi by 2, if I substitute pi there, if I substitute only pi over here, let me go to that. So I'll just take it as pi. So I'll just bring this down. So here it is. Here it is only pi for me. So I'll take it as pi. Instead of pi by 2, you have to substitute as pi. That means this formula is the same. But what you have to do, instead of pi by 2, you have to substitute as pi. Because I have got, in the case of the second one, I have got as pi. See here, I have got as pi over here. J pi, it is not pi by 2. So that one I am substituting. I get it as minus 1. Right? Did I get it as minus 1? Yes, I got it as minus 1. And now I'll take once again it is plus x of 3 into what I can say, that is your e to the power of minus j 3 pi by 2 plus j. I'm sorry. It is plus j over here. I'm really sorry for that. It is plus j, what I can say, the 3 pi by 2. Just a minute, I'll do it. It is 3 pi by 2. Yes, 3 pi by 2. Why 3 pi by 2? Because pi by 2 into 3 is telling me 3 pi by 2. So now if I substitute 3 pi by 2 here instead of a pi, so let me just take it. So I'll substitute 3 pi. So I'll just bring it down. Just a minute, I have to bring it over here. This is the, okay. This one 3 pi by 2. Just a minute, it is 3 pi. Whereas 3 here is 3, and here it is what I can say, my 3 pi by 2, right? So if I do this, I get it as minus I. What I got? I got it as what I can say, the minus I over here, right? Minus I. What I got? I got it as, first for this I got it as I. I got it as I for this one. I got it as minus 1 for this one, and I got it as minus I for this one, right? Yes, what does that mean? That means that in your IDFT, what I can say, the matrix you had in second row, that is I, that is minus 1 and minus I along with 1. So this one only we have got it here, right? Yes, in the DFT and in the IDFT also we are following the same. So now if I simplify, I'll only do for this one. So I hope you understood the standard equation whatever we've got, and that equation you're going to follow for all the things, right? You're going to vary the values of k and you're going to keep the n values as constant. Your n value will be constant for all, but your k values vary from 0, 1, 2, 3. So here it is what I can say, my 6, and here it is what I can say, have got it as that is minus 2 plus 2j 2I. So into I. So here what happens is you have to put a bracket over here without fail. So don't multiply. Please do put a bracket and multiply. Right? Don't directly multiply. If you directly multiply, you won't get the result. And that also I've tried and tested. I showcased you in the calculator. Please do see that. So my next one is, so it is what I can say, I've got it as minus 2 into what I can say, the minus 1. Right? And once again it is what I can say, that is minus 2j into what I can say, minus I, right? Yes, into what I can say, that is your I, right? Yes, just a minute, I'll just erase this and write it neatly. Yes, so now we got it. So now what you have to do is now, so you have to just check with it, this one. So this is a minus 2 plus 2I into I. So let me put bracket for minus also, because it is minus 2 plus 2I. That is right. Okay. So now here you have to take, if you take, so see here, if you take minus 2 plus 2I, what I can say, into I. So into y. So I'll showcase to you and everything in a clear manner. So it is minus 4. Right? You get it as minus 4. Let me assume that I got as minus 4. So let me write it as my minus 4. So I'll write it as 6. You got it as minus 4. You saw, right? Yes, 6 minus 4. Right? So now I'll take it as minus plus 2, and here if I substitute, what I can say, minus 2 minus 2j, what I can say, into minus I, what I get? I get it as minus 4 once again, right? I'll just substitute minus 4 over here, right? Yes. If I do that now, so just a minute students, I'll just go to this particular, this is plus 2i, right? Okay, so plus 2i, which is equal to, here it is, just a minute students, please to wait, equal to, yes, okay. So now you have seen what you got the resultant for this in calculator as well as this in calculator. So now let me move upward. Hmm. So now if I simplify this, 1 by 4 into, that is, if I take, let just a minute, I'll put 6 minus 4 plus 2 minus 4. What I'm getting it as 0, right? So I'll get it as 0. So if I'll get it as 0, 1 by 4 into 0 is 0, right? Which is wrong answer. Why wrong answer? Because my original answer is 0, 1, 2, 3. So from the DFT of this 0, 1, 2, 3, whatever I have got, I have to recover this resultant back, right? But I couldn't recover this resultant because this is what is my x of 1 that I am solving, and for my x of 1 I got it as 0. Just a minute. So sorry. This is what is for my x of 1. I am going to getting it as what I can say the 0 once again. So this is wrong. So that is why what I have to do is, so I have to just what I can say put a bracket. That is why I told you to put a bracket over here. So you need to multiply this with brackets. How? I'll just tell you just a minute students. My battery is low. I'll just put it on charge and start again. So I guess this is useful for you because your calculator has been shown on the screen, and what I can say, it has been displayed. Fine. Yes. So now I guess it's still more brighter. Yes. So now if I have to put all this in brackets. So if I put this in brackets, I'll just erase this, and what I can say, or else I'll just rewrite it. It's okay. Fine. So let me take a bracket. So that is minus 2 plus 2i. You can put it like this also into what I can say I, or you can put it as multiplied by I. So this is what I am getting, minus 2 minus 2i. So here what you can do, you can put it as into also. If you put it into also, you get the same, right? Yes. So now I got it as minus 2 minus 2i. So now I'll write it as, this is what is my first case. Right, my second case is that I'm going to showcase to each and everything clearly so you understand, right? So this is what I can say 6. The 6 is same. So here I got it as minus 2 minus 2i. Now this one is minus 2 because minus 2 into minus 1 is minus 2. I guess you got it, right? How minus 1 is over there, right? Yes. So how minus 1 is over there. Now here it is what I can say. I'll once again take minus 2 minus 2i. I told you, you can even take what? You can even take into also, or you cannot take, you don't want to take into also, it is fine for you, right? Yes. So if you take into, or if you don't take into also, you get the same resultant, right? It is minus I. So if I take this, what I get the resultant? I get it as minus 2 plus 2i. What is this? This is what I can say my, this one, that is minus 2 plus 2i. So if I take minus 2 plus 2i, so I'll write it over here. It is what I can say, minus 2 plus 2i, right? So I'll just simplify this on the calculator now. I get 6. I'll just put it on. So it is 6 minus 2 minus 2i. It is minus 2 plus 2i. You got it? Now, yes. So now if I put it, just a minute students, I'll just clarify. Just a minute. I'm really sorry for the distraction. Wait a second students. Yes, yes. So it is what I can say. Just a minute students. I'll just clarify to you without fail. So it is minus 2. So yes. So just a minute students. Wait for a second. So here it is what I can say here, minus 2 plus 2i. I'll just make a check and tell you. Wait for a second, students. Please don't get confused by seeing all this. Okay. So here it is what I can say here, I, right? Yes, I, and x of 1 is minus 2 plus 2i into I. I will just substitute it in this calculator itself. So wait for a minute. Sorry for the distraction that has happened over here. So please do oblige. Correct. Minus 2 minus 2i. This time I will bring it down. And it is minus 2. So it is minus 2 minus 2y into minus 1. Correct. It is correct, right? Just a minute, student. Just a minute, student. So sorry for the distraction. So we'll clarify it really soon and we're working on it. So sorry. So it is what I can say here. Minus 2 minus 2y plus 2. Yes, so here I got the clarification. Here it is plus 2. So that is why we missed something I got to know. So here it is plus 2. So if I, what I can say, put, what I can say 6 minus 2, or I can say minus 2i. I'm really sorry for the distraction. This is plus 2. Okay. So that is why I just checked where did I missed it, right? And here it is plus what I can say 2 minus 2 plus 2i, right? Yes. So if you substitute to get it as 4, what is the resultant? You get it as 4. So you get it as 4, that is 1 by 4 into 4. So what is this? This is what is my 1. So now I got it as 1, right? Now I got it as 1. So this is what is my resultant. I got it this as 1, right? If you follow this method, just a minute, I'll come up. Yes. If you follow this method, that is if you directly multiply like this. If you multiply like what I can say minus 2 plus 2i, yeah, into what I can say I, if you do, where is I, yes, if you do, so you're going to get it as minus 4, which is really wrong. This multiplication methodology is wrong. So what you have to do, this is really wrong, what I'm showcasing to you here, minus 2 plus 2i into I, this methodology is wrong. So what you have to do, you're going to take a bracket, you're going to multiply minus 2 plus 2i, what I can say, that is into I, right? Into I, you will get the resultant as minus 2 minus 2i, that is this resultant, and this particular methodology is a proper methodology to what I can say solve the particular this thing resultant, right? If you do this methodology only, you are going to get your particular resultant, and like this way you are going to solve for all the others without fail, right? For all the others, what you have to do, you have to just a minute, I'll just go back. For this particular, you have to write the equation first, that is the what I can say expression in the sense what I can say your formula first, and then you're going to write like this. So then you're going to write all these things, and after writing all this, so this one if you have to write next, and after writing this one, so this is super important formula that you have to by heart it without fail. If you don't understand, if you find complex to understand, then just try to by heart it. I have already explained it to you this in a clear manner. Please do try to watch this video. If you still don't understand, if you still feel that it is complex, just by heart it without fail. Okay, just by heart this without fail if you find it complex. So please do watch this video once. If you understand, it's fine and good. If you don't, then it is a complex, then you try to by heart it, right? This one you have to by heart it without fail. For this only you are going to substitute the values of n. Your k values are substituted. Your k values are varying. See, here it is 0, here it is 1, here it is 2, and here it is 3, right? Just a minute. 2 is not written clearly. I'm really sorry. Yeah. Yeah, here it is 0, here it is 1, here it is 2, and here it is what I can say my 3, right? So all this what I can say the values are changing. The k values are changing. This is what is my x of k. Here, this is what is my x of k. I am substituting the value of k, so k over here, wherein all these values of k are varying and my n value is constant. So that is why I kept it n like this only. See, I have written only n. I haven't substituted the values of n. So after I get this equation, that is this important equation, for that equation I am going to substitute the values of n. That is for n is equal to 0, I am going to substitute and get the resultant. That is for all, wherever the n is present, this n is present. Wherever small n is present, I am going to substitute 0. And next I come to what I can say, my this one, that is what is your n is equal to 1, and I substitute wherever in the place of n I substitute 1, like that I go on, right? That is what you're supposed to do. And here you need to learn this as important, and from this as important equation only you're supposed to solve. I've taught you how to solve for all the things as I have shown for x of 0 and x of 1, right? I have shown for x of 0 and x of 1. So for x of 2 and x of 3, you are going to do it without fail, and your resultant should be this. Your resultant should be this 0, 1, 2, 3. So this is what is my resultant that you have to get, right? And this is what is for what I can say the today's lecture. And I hope you understand how to solve this using your formula method, right? How to solve that particular question, what I can say using the formula method. And one more thing I told, I would be clarifying it, and that one also I'll be clarifying it to you now. Just a minute, students. Yes, so it is what I can say, my yeah, just a minute, students. I'll clarify that also to you soon, so please do wait. Just a minute, students. Wait for a minute. I'll just clarify that also without fail. Yes, yes. So let me just clarify to you soon. So please wait for some time. So just a minute, students. Wait for some time. So, or else I'll just, if I can't do it now, I'll just add another video about this and clarify it to you today itself. So that is, I had told you that I will be clarifying it with respect to phase angle. So I'll be clarifying it to you soon now itself. So please do make sure that you just watch this video without fail, and you just understand the concept very clearly. I've shown for two of the things, you need to do for all the others, that is the same, right? For all the others it is the same. So that is why I showcased you with respect to this formula method. So if I do one of the two, you can do all the others without fail. So that is why I just did this, and this is what is for today's session. And please do watch this. If anybody is in need of it, please do share it to them so that it would be helpful for them. And thank you.